Every time Elon Musk posts about AI, the internet divides into two camps. Some see the future, others see a masterclass in hype. And when he announced that Tesla and xAI are building Macrohard, a system designed to eventually emulate entire companies, the name alone drew skepticism. Welcome to the AI Verdict Audit. Today, we are digging through SEC filings, hardware roadmaps, and the actual technical architecture to determine whether this is an engineering reality or a marketing stunt. While the internet treated the name as a joke, xAI's legal team treated it as a priority. They have already filed an official trademark application for Macrohard with the U.S. Patent and Trademark Office. The financial paper trail is even more concrete. On January 16th, Tesla disclosed in a regulatory filing that they entered an agreement to invest roughly $2 billion into xAI's Series E preferred shares. The framework for these companies to collaborate is now a matter of public record. Tesla and xAI are pooling their physical and digital assets into a legally verified blueprint for enterprise automation. To understand the architecture, think of Daniel Kahneman's dual process theory of the human brain applied to a computer. System 1 is the fast, reflexive thinker. Musk calls this piece Digital Optimus. It runs locally on your machine, powered by Tesla's edge inference hardware, specifically a $650 AI4 chip. This local executive watches a rolling buffer of the last 5 seconds of your screen. It processes that video stream through a vision model, figuring out exactly where to move the mouse, what button to click, and what text to type in real time. But System 1 needs direction. That is where System 2 comes in. Grok sits up in the cloud as the strategic planner. It decides the overall goal, like finding Q3 revenue and pasting it into a report, and hands those instructions down to Digital Optimus to execute step by step. The muscle behind that strategic brain is already online. xAI's Colossus compute cluster is publicly documented at 200,000 GPUs, with a stated roadmap to reach 1 million. The cloud side of this equation is supported by verified hardware receipts. By relying on a short 5-second window, the system captures pairs of screen visuals and mouse actions for training data without requiring massive amounts of local memory. However, compressing a powerful vision model to run on a cheap microchip across thousands of random enterprise applications remains a significant engineering hurdle. Musk claims no other company can do this. In reality, the race for computer-using agents is highly crowded. OpenAI is already deploying their operator product, and Anthropic has built computer use features directly into Claude. The actual competitive advantage here is vertical integration. This stack combines Tesla's custom inference chips for cheap local processing, xAI's massive cloud compute for reasoning, and the X platform to distribute it to hundreds of millions of users. This closed-loop system is a direct play for the enterprise market. By processing data locally and only using the cloud for high-level planning, xAI can compete with Microsoft on price and data privacy, two primary friction points for corporate AI deals. There is a much larger objective hidden inside this software. If you can train an AI to navigate digital tools through a screen, you have built the foundation for physical robots to do the same in the real world. The desktop environment is a high-volume training ground for the physical fleet. This makes Macrohard a Trojan horse. It functions as a competitive enterprise product today while generating the immense volumes of behavioral data needed to train a future robotic workforce. Engineering ambition is not the same as market deployment. Before this system can sit on a single corporate network, it has to survive 3 real-world roadblocks that could break the product entirely. The first hurdle is security. If you give an AI control over your keyboard and mouse, it becomes vulnerable to agent hijacking. In this scenario, malicious instructions hidden inside a regular email or web page trick the AI into executing harmful commands on behalf of an attacker. xAI is aware of this flaw. Their own Grok 4 model card explicitly details testing the system against security benchmarks, like Agent Dojo, to measure how easily the model can be compromised by hidden text. The second hurdle is regulation. Starting in August 2026, the European Union's AI Act will impose strict requirements on how general-purpose AI handles sensitive data, creating a massive compliance bottleneck for any company trying to automate enterprise work. In the US, the FTC is already pursuing enforcement actions against deceptive AI marketing. Claims about emulating entire companies will face intense regulatory scrutiny if the product fails to deliver on that specific promise. The third hurdle is governance. This project sits in a web of Musk-controlled companies. Active shareholder litigation over potential conflicts of interest makes enterprise buyers nervous about vendor stability and intellectual property ownership. High-end edge compute engineering is only one half of the battle. If a corporate security officer or an international regulator blocks the system at the firewall, the technology remains a theoretical achievement. Here is the verdict. The Macrohard initiative represents a rare vertical integration of edge hardware, cloud compute, and consumer distribution. It is a calculated move to control the entire stack of digital work. Building the technology is the first step. Surviving the legal scrutiny and security requirements of the enterprise market presents a challenge that the engineering phase hasn't yet addressed. Solving the math is one thing. Surviving the compliance firewall is another. The final question is one of trust. Would you realistically allow an AI agent to have unmonitored access to your work computer's mouse and keyboard? Let us know in the comments and subscribe for more audits on the reality of AI.